Hi, David. Oh, you are muted.
How's the Edmonton plan coming?
It's all right. But I mean, they haven't announced the open dates now with the new variant. I still have 3 months after they open, so it'll be earliest March.
Oh, wow. Oh, okay. Quite a while then. Have you already started work or it's just...
Yeah, I stored, it's been 2 months I've been working.
Nice, nice. So what's the primary goal of the lab? Is it just to apply reinforcement to any learning to everything and anything, or do they have...
No, it's not at all about reinforcement learning. It just happens that a lot of projects go that way because a lot of the faculty have that experience. But it's basically a consulting, at least the place I am at is a consulting for companies who want to use AI for their problems. It could be anything. We do machine vision stuff,
Oh, okay.
NLP.
So it's actually a
Yeah,
business that's run out of the university.
yeah, I mean, they've established it as a nonprofit.
Okay.
Yeah, so it is funded by the government to help, I guess, the local and Canadian economy, I guess.
Right.
So some of the projects are subsidized for smaller companies or for different types of projects.
Uh-huh. Cool. Well, I might have to take you up on that. Morning, sir.
Hello.
Good morning now.
Good morning.
How you doing, Pime?
I'm good. How are you?
Yeah, so David told me you got a real interesting job.
Yeah, I mean, I find it interesting. I guess I've only started a couple of months. I'm still reserving judgment, but yeah, I found a place where sort of in the intersection of academia and industry, and I get to work with both the professors and sort of the companies who want to get things done. And yeah, it feels like the right place for me because I'm not that academic and I'm not that industrial. So it's like a good place.
So are you sort of a go-between? The sort of the liaison between industry and academics in this area?
I don't know if I call it liaison. I mean, I still code and like I have to do stuff. So I guess the official title is technical lead. So basically I have to scope the projects, decide what needs to be done, what approach, then go find the professors that are probably helpful for that approach, get them involved. And as you probably know, like controlling professors is like herding cats, you know, they have their own interests. They don't want to do anything you want them to do. So it's really, it could be challenging.
All you have to do is find the grad student, right? Because that's all they tend to do is they just point you at a grad student.
But that's the other side of the issue, right? So that's basically we get students to do most of the work, like we call them interns or associates and stuff. But the students are also like super theoretical minded and they basically follow their supervisors. Like they don't know what's happening in the real world or what companies need and what scope is, what timelines are, you know, they just do their thing. Yeah, so it is fun, but it is challenging.
No, I mean, it actually sounds like a lot of fun.
Yeah, what I like the most about it is I get to work on like 4 or 5 different projects and they change on like at the latest, the longest one is 2 years, the shortest one could be 4 months. So I get to learn about like completely different domains. Like we have project in supply chain management and then sort of machine vision, generating like fake videos and it's like completely different. So it just makes it fun. Like I get bored focusing on one thing for many years. So
as do we all.
Well, I know some people really like to specialize. I have friends who've done something for 20 years. They take pride in it and they know every little detail about it, but that's not for me.
Hi, Robert, the other Robert. I'm not sure if you're there, but we see you there. Rose can't join us today. So yeah, so I was hoping to dive into incommensurability and talk a little bit about that. But I did post some, I don't know if anyone saw them, I did post some questions in the forum. I'll just read them out so that we can kind of have them in mind.
And did you post them? I usually get a notification. This time I didn't. Did you tag our names?
Oh, I post them in ML/DS and philosophy and alt deep.
Okay, but you didn't tag our names, right?
I can if you like. If that's what you would prefer, I'm happy to do that.
I mean, that would be helpful because I'm
Okay,
not on
no
that
problem.
platform
I'll do that
on a
in the future.
daily
I just,
basis.
yeah, it's opt-in, not opt-out. So if sure, if that's what you like, then let's do that.
I appreciate it. Thank you.
Yeah, no problem. So the questions I came up with were, does a paradigm encompass some kind of data generating process? I think that it does. What role do cause and effect have in defining a paradigm? And is a paradigm a set of beliefs about a web of cause and effect relationships? So what I'm trying to get at is a paradigm kind of like a little mini religion where you have a set of core beliefs around a particular subject area, and you unfold those beliefs, you unpack those beliefs to create all the puzzles and all the science based on those initial foundations. And paradigm shifts occur when the fundamental underlying beliefs are proven to be false. And then you would go through a schism and actually undergo a paradigm shift where much of the puzzle solving that was done on the previous set of beliefs is invalidated. This is the Kuhn loss that's talked about. And then we start to unfold a new paradigm, or the altered paradigm, but we have to essentially redo all the puzzle solving we did before with the new paradigm to solve all the different problems. Does that sound right?
So there's one thing it's been a while since I read Kuhn, but maybe correct me so I thought, are you saying that first one paradigm sort of ends and then people start working on the other one? Because I feel like there is multiple things happening in parallel, and the dying of a paradigm, it just means people start favoring the second method over the first one. Is that true, or is Kuhn saying that the second paradigm does not exist? It sort of begins once the first one dies.
You will, okay, so the underlying thesis is is that they're all likely to retain a body of followers, right? So a new paradigm will emerge, but the old one won't die, and you'll end up just having two paradigms that are essentially competing. And this paradigm solves useful problems in a useful way, otherwise it wouldn't have been a paradigm in the first place. So the older paradigm still works. The new one works better in certain circumstances, but both are held. And his idea was that science is like evolution, and that these subject areas keep speciating and speciating and speciating, and you end up with all these different species of scientific disciplines that are incommensurable with one another because they have subtly different belief systems or exemplars.
Well, I don't know if they're incommensurable. I guess that's where I'm getting at. So I guess the model I use in my mind is like if you go back to the history of AI, is the connectionists and then the symbolic people, right? Connectionists are what we call deep learning people now, and then the symbolic people. And you could argue that the paradigm of symbolic logic went away, and then the connectionist people are now running everything. But then I think at some point you always see the two basically merging into a third paradigm. Although that didn't happen in like Newton versus like quantum mechanics or Einstein, because that's a sort of a qualitatively change of worldview. So I feel like it's complicated. Like, I don't know if you can say a simple story, because yeah, I think all options are on the table, right? The paradigms can join, one could die, the other one, they could both be useful. One of them could be useless. Like alchemy was probably a paradigm, right? At some point, but now we would argue that it's completely useless. It's not gonna continue in parallel with chemistry. So yeah.
So do we measure it in that way, or do we just count the number of alchemists that happen to be around? In other words, I think that if somebody in the 16th century could hold the view that it made sense, somebody in the 20th century can hold the same view. Why not, right? So
I mean, because we know a lot more, right? I mean, they
but
could.
The people who are in that practice may not be aware of the exemplars or the paradigms, other paradigms, right? This is the only paradigm they know.
Yeah, I mean, I guess you could say the same thing about flat earthers, right? I mean, they could hold that paradigm too.
Yeah, but from our point of view, right, we don't see the world in that way. And this is the other point that Kuhn makes very clear, which is if two people are standing in the same place at the same time looking at the same thing, they perceive completely different things, because essentially, I believe and this is talked about in the article a few different times. So the philosophical term is constructivist, but that comes with all sorts of nuances, which I don't want to get into. So let's just use the word generative or data generating process. So we have a data generating process that generates certain outcomes, and the foundation of that are these a priori cause and effect relationships, right? The underlying causes, as it were. And I think what Kuhn's trying to say is we don't remember paradigms, we construct them causally, right? So we generate an explanation for what we're seeing. So when we're standing looking at the view at the point, we see the image, right? We perceive the image, but in order to understand what we're looking at, we're actually reconstructing it in a data generative sense. We're generating a story, an explanation, a kind of a narrative that leads to the generation of everything that we see. And if we see something in the picture that we can't seem to generate, it will stand out to us and glare at us saying, yeah, I shouldn't be here, right? And so if I have two different generative processes and I'm trying to explain the same phenomena, I might explain them in very, very different ways. And I think this is what Kuhn's trying to get at with the idea of a paradigm, which is the way in which we see the world is the way in which we unfold our causal understanding of the world, the way in which we generate these explanations. And that's what defines one paradigm versus another, which is the explanation given of a particular phenomena.
So that's what confuses me, I guess. Is it always the case that when you go from one paradigm to the other paradigm, have you made progress, or could you have gone back, or is there a way to tell?
There's no progress in science. This is the really weird thing. There's only speciation. So,
well, that doesn't make sense to me. Like, why? What do you mean there's no, are you saying
so the positivist view is that science is all going to come together and we're going to have a single perfect theory of everything, right? So that's the positivism view, which is science is convergent, right? It is converging upon the one and absolute truth.
Well, that's the extreme view of it, but that's a different way to say we're going to go to the ultimate truth versus we're not making any progress. That's the other extreme.
Is a mouse better than a beaver? That's a silly question to ask, right? It doesn't mean anything. So is chemistry better than physics? Doesn't mean anything.
No, but our knowledge of, let's say, chemistry now is way better than our knowledge of chemistry 20 years ago. You know more stuff. You can explain more things. You can predict more things. You have gained knowledge that you didn't have before. It's not just going in cycles and people making up stories. That's what it used to be when it was all, I guess, philosophy and religion and all that stuff. But I mean, don't be argue like the science is sort of, by correcting errors, you're making progress. You know more overall, regardless of this story you tell in the background.
I mean, I'm not a proponent of any of this, but let's look at, that's a very good. So the key word that you used there was, just trying to look for that word. So we know more. We have moved closer to it. Is our generative model from now able to explain more phenomena more accurately than 20 years ago?
Well, make it 100 years ago to make it even more clear. Isn't that obvious that it's a yes? No?
It's not obvious to me, but yeah.
Okay.
So, but maybe it is obvious. Rob,
one of the interesting books I read is one called Comstock's Philosophy.
Okay.
No.
Unlikely to have heard it. It was kind of a natural science text from, I don't know, the mid 1800s. And it was something that we'd had in our family.
Mm-hmm.
But it's really interesting to go back and read sort of, 200 years old state of the art. And yeah, I mean, it kind of depends on what you'd want to define as the boundaries of a paradigm shift. But there have been a lot of it. And, you know, the way I see it is that, I don't know, knowledge is kind of like dots on a balloon, then you blow it up. And as you do that, all the dots start moving further away from each other. And there's all this sort of empty space in between that's sort of interesting areas of overlap. And then if, you know, it just sort of creates an incentive, I guess, to try and explore those areas.
Mm. Absolutely. I mean, to answer your question, I actually found great virtue in reading books that were 2,000 years old, 300 years old, 500 years old. Smart people existed in the past. They were really, really smart. Kant is a very, very smart man, no question about it, right? Aristotle is an absolute freaking genius, no question about it. No argument, like, yeah.
Yeah, I totally with you.
So these are very smart people writing down the best that they could come up with in their era for a generative model of, you know, an explanatory model for the world.
So, you know, I guess in answer to Piam's question, you know, Kant was what, like 500 years ago?
1750.
Oh,
so.
that late. Okay, so.
Sorry, no, 1680. Sorry, 1680. Sorry, yes. About 500, yeah.
Okay, yeah, within rounding area. I mean, boy, if I match him up against a lot of what passes as sort of conventional wisdom and state of the art, you know, I've got really good thinking in here.
Right, yes.
And really crappy thinking in these other areas. You know, take a look at the other books sitting on my desk.
But I think we need to make a distinction, right? Like philosophy is a strange case because you could argue, like it seems to be going in cycles. Like even contemporary philosophy, like if you look at ethicists, they become utilitarian after a couple of decades. They become sort of like Kantian, and then they go back and forth, and then they keep the cycle repeats. You can argue Aristotle said all we know about philosophy already. After that, people are just going in circle and they don't know anything. But that's not true for science. That's what I'm saying. Like when the first person discovered that there are germs and you can use antibiotics to kill them, you learn something. There is a jump. It doesn't matter how smart you were before this discovery was made. You were completely useless when it came to like dealing with germs. Once somebody, it doesn't matter. It doesn't even have to be the smartest person. It could be just an accident. I'm just saying that there is these gains of actual absolute knowledge that changes everything. And that kind of thing doesn't happen in philosophy probably, but it does happen in science and math and other things where, so Aristotle is, if having lost on 1,000 years of knowledge gain, they'll be just as idiot as a 4-year-old, no matter how smart they are, because they have missed out on that amount of information that they don't have access to. It's kind of like trying to write a book without having access to Google. Of course, somebody who is half as smart as is you and have Google, they can do a lot better job because they know more. So sure. I guess I want to make that distinction between the kinds of areas where you don't really make progress. It's just maybe a matter of perspective and opinion. And I don't know, like philosophy to me has not made any progress whatsoever since Aristotle. It's just going in cycles. I mean, it's interesting to talk about it, but it hasn't achieved anything. You don't know anything after reading more philosophy for like 1,000 years, at least as far as, maybe that's a little bit extreme, but.
I mean, I've been listening to go back to Rob's point, I've been listening to some modern, well, quote unquote, modern 20th century philosophers, and they don't even hold a candle to Kant. Like not even a candle. Like it's just.
I mean, they have different goals, right? They want to publish, they're like, that's their job. They want
to have
right?
lots of people say, I like your book. Kant wasn't trying to do that. He couldn't give a shit if you can't understand what he's saying. That's your problem, right? He was just in there trying to explain it all. I don't know if there's been a lot of progress in philosophy, to be honest. I have studied it fairly widely, and I am often.
What does that even mean? Like, can we even like quantify?
How would you measure it?
Yeah, exactly. I don't know what that means.
No, that's not a good response. The question is, how would you measure it?
Well, I think if something doesn't change after a while and everybody agrees on it, that's a good, I mean, it's a proxy. It doesn't answer what kind of things will be like that. But if, let's say, all philosophers at some point started agreeing that they found the truth and that's unchanging, or at least for that moment in time in history, they found the truth, that's a good sign that there is something. But if everybody disagrees with everybody and that keeps changing, that tells me people are just arguing their points and there's no progress.
So philosophy has morphed, in my opinion, good philosophy, whatever you want to call it, scientific philosophy has morphed into cognitive science, right? And that is one of the most active areas in academic study going right now, as far as I can tell. There are like massive...
Is that philosophy or is that like psychology? Like, I don't...
All of the above mixed into one. So the phenomena that is discussed in philosophy is mapped into cognitive psychology and is actually even being mapped into brain structures. Right. Rob sent me an amazing paper on reinforcement learning, agent-based reinforcement learning, where the agents actually generated behavior that they could measure using fMRI in real people. Right. So here you're seeing this kind of fusion between the philosophy, which is the underpinning. Well, certain philosophers are the underpinning, Kant specifically, but you have an underpinning of philosophy, and then you have a layer of behavioral cognitive science, which is the study of behavior. And then underneath that, you then have the neuropsychology and the neurophysiology, which is trying to map this into brain structures. So I would argue we are actually making progress in mapping concepts from science into philosophy. I don't think the philosophy itself is being transformed. But,
so how do you, can you give an example? Like to me, those things are completely disconnected. How do you map physiology of the brain to philosophy? Like, can you give an example of what would be such a mapping?
Sure. Let me do that.
Because I guess in my naive understanding, like philosophy is dealing with what you should do and all that, not how you, I mean, it's almost like trying to map so what you should do on a daily basis, given your atoms in the universe. Like you could maybe connect it, but they're irrelevant.
No, I'm not disputing. I'm just trying to give you so Kant, I think, is different. I wouldn't actually call the critique of pure reason philosophy. I wouldn't, actually. I wouldn't call it philosophy. I would call it speculative neuroscience, basically. Okay, so let me share my screen here for a moment, and I'll just share some of the things I've been working on this week. Okay, so I think you can see that picture. It's not a very exciting picture.
Yep.
So yeah, so we start off at point A here, and we're trying to imagine what it's like to be at point B, right? But we can't physically travel there easily, right? So I'm imagining what it's like to go to my favorite coffee shop right now. Would it be busy? You know, would it be loud? Would it be quiet? You know, I can imagine what it would be like to do that. How do I actually achieve that? So in Kant's critique, he talks about the manifold. Well, he has a much more sophisticated name called the unity of synthetic unity of apperception, which I won't go into, but he talks about the manifold. And in machine learning, we often always talk about the kind of the shape of the weights, right? We have this manifold, which we're essentially mapping through to have an understanding of what it is that we're seeing. So what Kant is trying to say, in my interpretation at least, is we see patterns in the world. We lift those patterns in the category theory. There's this really interesting idea called lifting functions, where you go from perhaps the category of set, which is the category of things. You can map that into a functional category where you can actually manipulate the things and do things with them in the abstract, which is what he's talking about with this manifold. you can then move the things across the manifold to a new place, and then you can drop down into experience and experience what it would like to be there. So, so we see patterns in the world. That is our experience. We can draw those into a different neural structure in our mind, which is often referred to as grid cells. So there's this structure called grid cells in the mind, which is essentially a kind of a weighted surface, which is very akin to a manifold. These objects that we're now grasping at this higher level, we can easily move and manipulate. And then once we've manipulated them to where we want them to be in the abstract, we can then drop down and imagine what it's like to see these objects if this series of events were to unfold. So in that sense, I'm trying to map philosophy into cognitive neuroscience, into experience, things like that. I'm not saying it's a useful thing to do, but I find value in this process in trying to reconstruct the mental processes that we use to do science and to move through the world, in the hope of actually reproducing that in software in agents. So that's, I'm very curious what you think of that.
So I'm interested, so the only connection, I guess, to neuroscience I heard was this concept of grid cells. Like, not knowing anything about grid cells would not subtract anything from the argument you just made. It's still perfectly coherent. And knowing about grid cell didn't add anything to this argument you put forward. How does it, I mean, I understand that it's intellectually interesting to think about it, but does it help with anything? Like, knowing that there are grid cells, does it help you make better agents in your simulations in any way?
Yes, because I can now use the concept of grid cells to create a software construct that mimics that behavior, a weighted grid where you have, you know, a covariance matrix between different cells in the matrix, right? And so if we have this covariance matrix sitting on top of the values, we can essentially navigate, we can use A star, I don't know if you know what the A star pathfinding algorithm is, but we can find efficient paths through this surface to get us from where we are now to where we think we want to be.
Sure,
and
but
so we can solve the problem algorithmically, the agent can come up with a solution and then drop down and use, yeah. So
yeah, but I feel like it's the other way, right? Like, we know about covariance matrices and A star and all that way before we knew about grids. If anything, the grid cells learned from this abstract mathematics and they evolved to reflect the reality that you already knew through math and covariance matrices and all that. So just knowing that, you already know something that the grid cells in our brain had to discover through evolution. So you don't need to know what, even if this was a new solution, it doesn't necessarily mean it's the best one. So, I mean, evolution, what came out of evolution to give us our brains is, I guess, one answer that you could use as a source of inspiration. It's not necessarily the best one, and it's definitely not necessary. But it is interesting. So.
Rob, what are your thoughts?
You know, at some level, it sounds like what you guys are dancing around is can we use the insights from philosophy to create a framework for kind of an AGI?
That's where I'm going.
So what is your answer to that question? I guess I'm answering, probably I can't see a way, but I guess, David, you're saying that that's a good way to go.
So you have to break it down into pieces, right? You can't just pull AG. My understanding is, at least, is you can't just create a 90 trillion parameter data thing and then pour all the data in the universe through it and you'll get AGI. That's not.
Yeah, I think I agree with you there.
Maybe, but that's well beyond my ability. So I mean, in the simulation that I've been working on, we have actually been able to achieve results that are actually quite plausible using a very mechanical kind of mind for the agents. I can give you an example of that. Let me do that very quickly. This one maybe. Yeah, let's look at this. Okay, so let me just share my screen again. All right, so yeah, so here's the student residence at UBC. It has 540 residents. And we were trying to work out where the sociability happens in the building. And what we came up with was that the conversations were mainly happening in these locations, right? And that's exactly where they're likely to happen, right? They're likely to happen in corridors, they're likely to happen in stairwells. And as agents move along the corridors, if there's a major stairwell at one end, the chances of you running into other agents at this end versus the other end is higher. So the simulation is generating very plausible results. And all that's happening here is the agent is essentially waking up and saying, oh, it's time for me to go to my class. And they walk out of their unit and they basically walk down to the end, they walk down the stairs and out they go. So we are getting reasonable results, but the backflips we had to go through became very implausible. We came up with a bunch of very arbitrary kind of rules to make the agents seem to behave normally, which don't have any basis in strong science at all, right? It was just a bunch of heuristics that we came up with to try and get results that look plausible. That's not very scientific.
What were those?
We created a spreadsheet where we have use cases, agent types, destinations, and we parameterize them with hyperparameters of a whole bunch of different kinds. And then that forms the foundation of the behavior of the agents. So essentially they are given a complete calendar of events in their kind of Google Calendar, if you will. And they just, like a robot, just do exactly what the calendar tells them to do and move through that sequence each day. And that's kind of the mechanistic view of agent behavior. And I'm trying to see if I can come up with ways to make that a little bit more realistic. That's all. So, and in our simulations, I'm also trying to imbue the agents with things like the endowment effect, right? The prospect theory stuff. And that's why that paper that you sent me is so interesting, is they actually managed to pull that off, where the agents within the simulation don't actually, oh, he's trying again. Let's see if he can join us. Oh, he's still connecting. Yes,
hey,
you're in. Technical
hey.
Problem solved. Welcome.
Hi.
So, yeah, so Payam, why don't you bring Robert up to speed? Where have we come so far?
Well, I guess I missed last week, but I guess the discussion was around Thomas Kuhn's paradigms. And I guess we started going a little bit sideways, where we started on a tangent. I was arguing that I guess when these paradigm shifts are happening, I was questioning, are we making progress or not? And I guess David was arguing we're not. We're basically going from one narrative to another. And then we got into another tangent of maybe in philosophy, we go in cycles, but in science, we're making clear progress. Yeah, I think that's roughly about it. I think we just disagreed on that. And then David was showing us how he's trying to join philosophy, psychology, neuroscience, and I guess AI
Agent simulation
to solve his, agent simulation to solve his problems.
Yeah. And the other point I was trying to make, Robert, just to be clear, is I think that there is cause and effect and the whole idea of causal data, a cause-driven data generation process lies at the foundation of paradigms, right? So when we have a particular subject area, there's a set of cause and effect relationships or exemplars or whatever you want to call it, that form the kind of the hub of that paradigm. And only when those kind of cause and effect, those fundamental cause and effect relationships are shown to be false, do we actually undertake a paradigm shift. So if we could somehow express or use a model to determine what the kind of underlying cause and effect relationships are within a paradigm, we might have a better chance of understanding, it more deeply and potentially even challenging some of those cause and effect relationships and potentially inducing a paradigm shift. So,
I suppose thinking of examples for like it depends on the paradigm, right? I mean, I guess one of the interesting things about AI is that it's not a conversation about what is, it's a conversation of like what's the best path to some objective, which even in the objective itself is a little bit nebulous. But so I think about paradigm shifts in physics or natural sciences, like for example, the example I guess that comes to mind is the going from the plum soup, is that what we called it? Plum soup theory of biology. Plum pudding.
Yeah, that's fine.
To the idea that cells have nucleus or nuclei, and then I guess I'm not sure if DNA was part of that or that came later. But I mean, so that's that's interesting in the sense that the plum pudding model was wrong. Like it was because I mean, it rejected the idea. Well, I guess so. Is it wrong? Was it wrong? Was it wrong, or was it just not sufficiently detailed? That's, I guess, where I'm trying to land when I try to understand paradigms. Like if, for example, like according to Kuhn, and I'm not sure this is how it actually played out, but that everybody believed in this plum soup thing, and the plum soup model was, from one point of view, right, just insufficiently detailed. And then somebody comes up with saying, like, actually, there is stuff floating around in the cytoplasm, but there's also this kind of thing in the middle called a nucleus where all the action happens. And then at that point, when it challenged the existing paradigm, people would have been like, that's wrong, and that's clearly not what the standard model is. And therefore they would have attacked it. At which point the original paradigm would have shifted from being merely lacking in certain nuances to being objectively wrong relative to, or relatively wrong relative to the more correct framework.
I think it can be both ways, right? Like there are clear cases where they were just absolutely wrong. They weren't like lacking in detail, like epicycles, like when they invented, because they assumed they must go in circles. It was just wrong. There's no way to say it otherwise. And it was proven wrong. True. And then there are other things like maybe Newtonian mechanics. Maybe it's lacking detail. It's not wrong. It still gets everything really correctly.
Yeah, that's the thing about physics. Physics feels like it's right, but then like there's probably a more right model out there that captures the inconsistencies that the current model can't capture. But like you can build a plane with this. like you can do, you can predict a lot of, you can even extrapolate really well with this model. And it's like that's kind of where, I mean, and I guess that's only that's the blessings of modern physics, right? I'm supposing, back when people believed in other kinds of stuff, then
I think I have a good way to connect it to cause and effect. Tell me if you agree with this. Like I'm saying, let's say there is some universal cause and effect relationships that we have no hope of ever finding out. That let's say there is this huge DAG that every level connects everything causally to everything else. We just don't know it. And then, so a theory is a combination of these guesses for these cause and effect links, as well as the nodes. And I think a paradigm shift is changing the nodes as well. So some of those links in the original DAG are still valid. It's just you're connecting different things as nodes. And that's the paradigm shift, because both theories presumably still need to explain the same kinds of phenomena. So those causal effect relationships, unless they're wrong, it should be consistent. But you could imagine having two DAGs that have completely different nodes. And so that's a different narrative that you have to explain the same observed phenomena.
So is the criteria then essentially better predictive power? I mean, if you go back to the celestial example, celestial mechanics examples, so the pre-Copernican version where, you know, you had the planets moving in cycles and epicycles and stuff, they had models for that, and that actually fit the data really well.
Yeah, they're very predictive. And meanwhile, the Greeks were coming up with all kinds of weird stuff, but it ended up turning into something that would be useful.
But they were overfitting to their data, right? So it wouldn't be predictive if they went outside of their domain that they fitted, which they didn't have a chance to do.
Well, I mean, in some sense, an alternative, you know, an alternative causal maps, like Robert said, can help resolve some of the inconsistencies they observe. So in that sense, you know, that's kind of the paradigm shift.
And the trouble with that branch of science was that, you know, you couldn't do experiments, right? So like maybe prediction is okay if as a standard if you're trying to do it if you're going to predict something out of sample or out of distribution, right? Because your science is capturing a mechanism that would describe what an intervention would do to the original distribution. But when it comes to stars and the skies,
is it possible? I guess, I mean, it's still a model and it's still a predictive. You still need a model to make any out of band predictive like estimate. You have to have some model that you can extrapolate from, right? So you can't just use association to generate out of band data. I mean, you could have a terrible model that was based on past observations and use that, I guess. But don't you need to have an underlying data generative process to even do extrapolation? Or am I misunderstanding?
But to do good extrapolation.
Yeah.
Yeah, I would agree with that.
Oh, interesting. Okay. Very interesting.
Yeah, so, I mean, the model could be pretty simple, but yeah.
But I mean, going back to your original question, I think prediction is probably one way to sort of falsify or have support for a model. It's probably not the only way, but I think it's one of the best ways we have, right? If you could predict the results of some experiment that you haven't performed yet, and you compare your two models, one of them is correctly predicting, the other one isn't. I think that goes towards falsifying the one that doesn't, right? I mean, that's one of the techniques by which science has progressed, right? By making some model that goes beyond what you already know and then testing it out and see if you were right or wrong. So there is a clear way you could be right or wrong. It's not perfect. You could still be wrong and get the prediction correctly. But if you get the prediction wrong, then you're wrong. So that's falsification, that asymmetry in the way you gain knowledge. I think that helps what I'm arguing, the progress, the real progress that maybe you don't see in philosophy because there is no prediction, there is no objective measure of progress.
Sure, I'm not arguing. But okay, so where I was going is this is what I'm curious about, and this goes right back to why I took Robert's course in the first place, which is how we generate these explanatory models, right? These predictive models. And Robert, I know you're writing a book on this, so this will be very interesting. But the means by which we can take observations from the world and then forge them into a data generating process, which we can then use to make predictions and refine using the fact that the predictions are right or wrong. To me, that's science, right? That whole mechanic of taking observations and going through some mystical process by which we turn that into a cause and effect, a set of cause and effect relationships that we then represent in a model. And then we can take that model and use it to make predictions. And then if those predictions
make a
are accurate,
distinction though, right? But you got to make a distinction, because like if you want to do it the AI way that the deep learning people do, like you grab a bunch of data, you don't know anything about anything, you just create a model based on the data that makes predictions. So that's, I would say, is very different than, let's say, whatever Heisenberg sitting in his bedroom, just having 2 data points and then imagining a whole sort of scaffolding around imagining it, writing one equation and then extrapolating to infinite data and then being right. So that's, I don't know where that comes from, the imagination that you come up with one idea that somehow connects so many different things together and explains huge amounts of the data, as opposed to just having a super flexible model that just fits your data. I mean, those are 2 very different things.
And this is, I think, the point that Robert was making around AI, which is AI is different to normal science, right?
Yes.
In what way is it different, Robert? Can you expand on that?
I think recently I just interviewed a woman who was working on learning theory, and you know, what the way that she worked felt a lot more like science to me. I mean, she would basically she studied neural networks and was trying to understand how and why they worked, and the engineering application of that knowledge is, you know, could you say, for example, just look at a problem and then use some, you know, use some kind of set of proofs to determine exactly what the right architecture is for that predictive problem. But the way that she kind of worked, and kind of asking questions and then discovering something and then validating it and then discovering more things and then running experiments, I'm like, oh, okay, so this is the science of the study of deep learning. And I'm like, okay, this is what science, because I mean, I guess broadly, if you define kind of the science of AI as like the various topics covered at a conference like NeurIPS, it's just there's too many different, you know, it's a bunch of people working on different problems whose methods happen to overlap, and so are interested in talking to each other, because if you figured out a way to, you know, optimize better or predict better in your domain, then I can probably use that in my domain, since we're using similar technologies to actually do it. But that's not how science works, right? It's not like, it's not a normative statement about how science ought to work. It's just like, typically, a chemistry conference is interested in, you know, understanding. I mean, I guess also you have to kind of put bounds around chemistry, but, you know, in other words, that they're interested in discovering something. While machine learning conferences, it often feels like it's about honing or improving methodologies, and there's less emphasis on discovery in the sense that you're trying to describe something true about the universe. It's more like, I don't know, maybe it's more akin to something like a CES conference. Like, hey, check it out, we got this new robot that can do backflips. And that's not a criticism, but it feels difficult to, within the AI context, to apply Kuhn's model of science when much of AI feels more like more like engineering.
Interesting. Okay, so you don't think that AI is technically a science? That's fine.
I mean, I think that there are elements of it that are, right. I mean,
elements, yes.
Or communities of it where like, for example, like I said, like people who are working on learning theory, people who are working on, which is, and learning theory is an interesting example to me because it's a science of something, of understanding something that, like an artifact that it's artificial, right? Like, I mean, neural nets are clearly based on, they're biologically inspired, but they're studying, neural network architectures in machines, not in heads.
It's also, I guess, another distinction that might be useful. I guess there is science, which is sort of study of natural phenomena, and then there is the scientific method. I think what you're describing is applying the scientific method to machine learning and neural network, which is amazing and everybody should do it. But it's not we're not discovering like some kind of naturally occurring networks in the universe. We're sort of creating them, right? Maybe, I guess that goes back to the whole philosophical debate of is math invented or discovered, but that's a different can of worm. Let's not go there.
And there's also like, if that's not science, then it's like social science as opposed to natural science. I would argue it is. I mean, like if so-and-so is using scientific method to study neural nets and his sister is using the scientific method to study, auctions in Bangladesh. Like, I mean, it's auctions in Bangladesh are just as artificial as a neural net. I mean, you can kind of, or maybe, you can see them as some kind of study of some kind of extension of anthropology, but still, it just, I guess all I'm saying is that's why I feel it's hard to talk about it in the context of AI.
One thing I always I'm struggling to get on board, and I think everybody just takes this for granted now. And I know, Robert, you must be also close to your heart coming from a statistics background. You're just looking at every process as a distribution. Like, I don't know, maybe that's like in science, you don't do that. The distribution is only used when you don't know things about your process. If you know enough, then it's not a distribution anymore. It's just meant to capture your lack of knowledge. Is that correct? But somehow everything is formed into this distribution. And this is what I would call a paradigm. But I think, I don't know how you could be shifted, but it's not necessary to view every generating process as a distribution.
That's an interesting idea. I do agree that, the idea that probability should come into play when there's uncertainty. I mean, I guess that's itself a philosophical argument, right? It's like, Bayesian epistemology or something like that. I guess, maybe people model distributions as, maybe whatever it's isomorphic to something else in the same way, like, you can, linear algebra and you can kind of think about things in terms of Gaussians, or you can think about them in terms of hyperplanes, right? And then maybe one's just easier to think about than the other. But I think it does seem like a kind of sounds like what you would describe a paradigm, like everybody kind of by default characterizes the problem as a distribution. But even there, it's like compared to like the plum pudding thing, or the or Ptolemaic astrology, astronomy. It's where those are clearly wrong, or those are objectively wrong. But like, is it wrong to think about your latent space as a distribution, or is it?
It's not wrong. It's just whether there are other ways of doing it that get you something that you wouldn't get otherwise. Like that's the question. Not that it's wrong. It's just one view.
And so if there's something that's limited, like if it makes sense if the abstraction of a distribution is limited to the extent that another abstraction would get you more, but then those papers are getting rejected because people are upset that you're not modeling it like a distribution. That would probably feel a lot more like what Clune's talking about.
Yeah. Of
I think
course, I don't have a
definitely
better idea of replacing it, but I'm just saying, giving this as an example of paradigm, because I remember when I first started learning about statistics and AI, that really felt really odd to look at like the distribution where all the natural images come from. That seems like an awkward way of thinking about natural images. And I mean, nowadays everybody takes it for granted, but I mean, I wouldn't be surprised if somebody comes up with a better way of looking at it.
because I think about like AI as kind of like a modern Manhattan project in the sense that like, I mean, number one, it's not top secret. Everybody's working on it across countries, but there is this kind of idea of a goal at the end that everybody's trying to like get some kind of breakthrough moments that shows that you have achieved some goal or some milestone towards that goal. And I guess with Manhattan Project is easier because you can just show a big explosion. But like, you know, if AI were trying to like, if the AI community were trying to do something like if somebody could show a big explosion and somebody be like, well, that's not actually an explosion.
Well, you could argue we've already seen that, no? Like all these amazing, like a huge language models, that's sort of like an explosion, right? Like nobody thought this was possible like 20 years ago.
Robin, did you have some comments? You posted a very interesting looking paper. Grokking is the term. I am familiar with the term. Did you have anything you wanted to add there?
No, I'm just listening. I'm sorry I came late, guys.
That's fine. Your insights are always very interesting. We're kind of coming up to time. I have a paper I'd love to chat with you about that relates to a lot of what we're talking about. So I might propose that. Rob, is it okay if I share that paper you gave me on?
Oh, yeah.
Yeah. Okay, just checking. So I'll post a link. I think it's behind a paywall, so I'll actually post the real paper. Which
one was that?
It's the, I'll show it to you, and maybe you can get it through independent means.
Yeah, I'll just go ahead and post it.
That's fine, I'm just checking. I don't want to kind of be a poor citizen. It's this one here. I'll share it with you. Very interesting.
I didn't get it through any nefarious means, let's put it that way.
No, but you work at an institution. So it's this one. Very interesting paper. And this one actually tries.
Yeah, it's an archive one, yeah.
Okay, cool. Yeah, all right, I'll post this. So this will be the paper, but what's interesting about this, it's a very long paper, and will post instructions on what to read and what not to read. So I'll read the whole thing and then try and give you a distillation. What's really interesting is this, which is they actually map it into, you guessed it, fMRI data. And so they're actually trying to show that you can use, we can actually model risk as a neurological process, right? So this kind of is the grand, like the crossing the chasm between kind of machine learning and neuroscience. It's a very interesting paper. I haven't read the whole thing. I spent a couple of days and I'm probably at around page 20 or something. But yeah, so I'd like to actually tackle some pieces of this, but as I say, it's probably a little bit too much for 1 week's reading group. So I'll try and post a summary or something.
So something we've never done here before, because it requires a lot of effort from one person or two people. But if you wanted to present the paper, maybe that's a good way we can cover it without requiring people to read a long paper. Sure.
I'd be happy to try and present the paper next time as an experiment. Let's do that.
If I can just add, it is a pretty old paper. I think a lot has happened in this area since. This is 2014.
Yeah. If you have a more up-to-date paper that's equally as interesting, I'm all over it. But I found this one to be very, very interesting in that they were actually able to model the endowment effect using mathematics, which I thought was pretty remarkable. And the fact that they then went on to try and map that into neurology is truly remarkable. So
yeah, I mean, you know, part of the underlying exercise here was to investigate what is in the RL world that incorporates risk-averse agents, and how to kind of feed that into the optimization process.
One of the professors I work with at Amy, Matt Taylor, that's his area of research, like safety critical RL applications. He has a bunch of papers on that, but yeah, I think we're still
once
far
again,
away
this is
from
just a token paper that kind of gets us into the realm. If somebody has a better paper, I'm very happy to read and present
like,
it.
You know, like Robin said, I mean, this is, you know, 3 eons ago or something.
Robin, do you have a suggestion for a more up-to-date paper that might be more salient to the group?
Offhand, I don't have a single paper. I have a large collection of papers on this topic that I would probably want to pick and choose different ideas from different ones. Okay. But I can't think of one that is.
Do you think it would be useful to go through this, or is it just so old that we're better off just jumping to the latest and going from there?
I don't know. I mean, my default thing is when I'm looking to get into something is try to look for a survey paper. So I'm not sure if there actually is a good recent one.
Well,
yeah,
I'll look around a little bit too, see what I can come up with.
Okay, but if we don't come up with anything, then I'm happy to do this one, just to try and get us into the space, and then we can look at more modern material, and this might provide a useful contrast. So, okay. Great. Well, thank you, everyone. I think we're at time. I think we can call it here. And as I say, I'll try and pick this up, and I'll actually try and present this coherently next time and see how we go.
Thank you.
Does that sound good?
Yeah. Thanks, everybody.
Okay, great.
Thank you.
All right. Thanks, everyone. Take care. Bye.